What if tomorrow had 25 hours instead of 24? Sounds amazing, right? One more hour to sleep, play, or relax. But here's the truth. Scientists say Earth really is slowing down. And one day, far in the future, our days could grow longer. The reason behind it is both fascinating and surprising. You know how we always wish for more time in a day? One extra hour could change everything. More rest, more fun, less rushing around. Well, believe it or not, Earth is actually moving toward longer days. And not tomorrow, not next year, but slowly, very slowly, our planet's spin is changing. So the big question is Earth really heading toward 25-hour days? Yeah, but it will take millions of years to get there. Let's break it down in a simple way. Long ago, before dinosaurs, before oceans, before anything we know, Earth was just a messy cloud of dust and gas floating in space. Gravity pulled all that material together. As it clumped up, it began to spin. Think of water swirling down a drain. And that spinning motion created momentum. And because space is almost empty, nothing was there to slow Earth down. So it kept spinning. That spin is what gives us day and night. One full turn equals one day. We say a day is 24 hours, but here's something most people don't know. A day is not exactly 24 hours long. It's close, but not perfect. Earth's rotation changes slightly all the time. Why? Because Earth is not a solid, perfectly balanced ball. It's more like a spinning top that shifts weight around. When heavy things move, Earth's spin changes a tiny bit. A great example happened during the 2011 earthquake in Japan. The powerful quake shifted parts of the ocean floor. That moved Earth's mass slightly inward. When mass moves closer to the center of a spinning object, it spins faster, like a figure skater pulling in their arms. That earthquake shortened Earth's day by about 1.8 microseconds. That's a millionth of a second. You would never feel it, but atomic clocks can measure it. On the other hand, when glaciers melt and water flows from the poles toward the equator, mass spreads outward. That slows Earth down slightly, just like a skater stretching their arms out. Most days are actually a few milliseconds longer than 24 hours. A millisecond is 1,000th of a second. Tiny, right? Yes, but over long periods, those tiny changes add up. Scientists wanted proof that Earth used to spin faster. So they looked into the past, thousands of years back. Ancient civilizations carefully recorded solar eclipses. When the sun suddenly disappeared in the middle of the day, people were amazed and sometimes afraid. Kings and priests wrote down exactly when and where it happened. Today, astronomers can predict eclipses with extreme accuracy. They even use mirrors left on the moon by astronauts from the Apollo program. Scientists fire lasers at those mirrors and measure how long it takes the light to return. That tells us the moon's exact position. So researchers tried something cool. They rewound the sky using computer models to match ancient eclipse records. But something strange happened. The moon didn't line up perfectly with the old records. The shadow fell slightly off from where it should have been. Why? Because Earth used to spin a little faster. When scientists adjusted Earth's past rotation speed in their calculations, everything matched perfectly. That means our planet has been slowly slowing down for thousands of years. On average, a day gets about 1 to 2 milliseconds longer every 100 years. That doesn't sound like much, and it isn't, for us. But over millions of years, it adds up. In about 200 million years, a full day could last 25 hours instead of 24. So yes, the dream of an extra hour is coming, just not anytime soon. Yeah, now here's the bigger question. What is causing Earth to slow down? The answer is simple and powerful. The moon. The moon's gravity pulls on Earth. It doesn't just pull on land, it pulls on the oceans too. This creates tides, the rising and falling of sea levels. But here's the key part. Earth spins much faster than the moon orbits around us. Because of this, the tidal bulges caused by the moon get pulled slightly ahead of the moon's position. This creates friction, right? And friction steals energy. As Earth's oceans move across the seafloor, energy is turned into heat. That heat escapes into space. Once energy leaves, it doesn't come back. So little by little, Earth loses rotational energy. The moon acts like a very slow brake. At the same time, something else happens. The energy lost by Earth doesn't just disappear. Some of it transfers to the moon. This pushes the moon slightly farther away from us each year. Right now, the moon drifts away at about 1.5 inches per year. That might sound scary, but don't worry. It would take billions of years for the moon to get significantly farther away. Still, this slow process leads to something scientists call tidal locking. Tidal locking has already happened to the moon. That's why we always see the same side of the moon from Earth. The moon rotates at the same speed that it orbits Earth. One day, very far in the future, Earth could become tidally locked too. If that happened, one side of Earth would always face the sun. The other side would face away forever. Imagine that. One half of the planet would be in endless daylight. The other half would live in permanent night. Scientists sometimes call this an eyeball planet. The bright hot side would look like the dark center of an eye. The frozen side would look white like ice. The side facing the sun would become extremely hot, a giant desert. The dark side would freeze into thick ice. Between them would be a narrow strip where temperatures might allow life to survive. But even there, conditions would be wild. Hot air from the bright side would crash into freezing air from the dark side. The result? Massive storms and powerful winds sweeping across the planet nonstop. The oceans would also change. Water would slowly move away from the hot side and collect in colder areas. Coastlines would shift. Continents would look completely different. Earth would not resemble the world we know today. But before you panic, here's the good news. This will not happen anytime soon. Scientists estimate it would take around 50 billion years for Earth to fully stop spinning and become tidally locked with the sun. And here's the twist. Our sun won't last that long. In about 5 billion years, the sun will run out of hydrogen fuel. It will expand into what astronomers call a red giant. During this stage, it will grow so large that it could swallow Mercury, Venus, and possibly Earth. So Earth will likely be destroyed long before it ever stops spinning completely. That means we will never experience 25-hour days in our lifetime. Not even our distant descendants will. Humanity's future, if we survive, may not even be on Earth. We might live on other planets. We could build giant space habitats. Some scientists imagine humans creating massive structures around stars to capture their energy. Others think advanced civilizations could exist as digital minds inside powerful computers, living in simulated worlds. Wherever humanity goes, Earth's slowing spin will continue quietly in the background. It's strange to think that something as simple as the moon pulling on our oceans is slowly changing time itself. Every sunset, every sunrise, every ticking clock. They are all part of a cosmic dance between Earth and the moon. So yes, Earth is heading toward longer days. Yes, one day could last 25 hours. And yes, eventually our planet's spin could fade away completely. But that story stretches across billions of years, far beyond human history. For now, our 24-hour days remain steady enough for school, work, sleep, and dreams. And maybe that's enough. If you enjoyed learning about how Earth's rotation is changing, make sure to like this video and subscribe for more amazing science stories explained in simple ways. There's always something incredible happening in our universe, and we're just getting started.